Hello everybody, my name is Richard Litz. Welcome to the Watershed Processing Lab for today. We're going to be talking about the continuous temperature probes and how to use them and calibrate them and stuff today. This is Casey, who's decided to join us. My background is I'm currently working as the tribal lamprey biologist for the Confederated Tribes of the Coos, Lower Umpqua, and Siuslaw Indians. And previous to that, I was the monitoring coordinator for the 10-mile watershed for many years. There's 10-mile lakes behind me. I live on the lake. And a few years ago, Tasha Livingstone and I came up with the idea for this class. Originally, the idea was to get all the students to have some hands-on experience with the equipment that I use sort of on a daily basis or whenever it's appropriate, and get it as a way for you to understand how to solve some problems as you come across them in your work, and hopefully just get some experience so you can get things on your resume and get a job in the first place. With the COVID-19 outbreak, we're not able to do that as well as we have been in the past, but hopefully you'll still be able to get some things out of the class that are valuable for you. Today we're going to be talking about the continuous temperature probe. This is a little piece of equipment that is made by Onset. They're called a hobo probe, and the idea of a continuous temperature probe is you're trying to get a stream temperature over a long period of time. You can also use other thermometers to get temperatures. This is a digital thermometer. In particular, this is a NITS thermometer, which is an indication that this particular thermometer has been calibrated and is within plus or minus 0.2 degrees centigrade. So whenever we're trying to calibrate something, we can rely on this. We send it back to the Department of Environmental Quality every year, and they recalibrate it and make sure that it's accurate. So if we're trying to look at this and see if this is accurate, we can compare it to the NITS thermometer and find that out. The question arises maybe is why we need this when we have this already. So this will take a very accurate temperature in a stream or lake or wherever you are, but it only does it for a particular moment in time. A lot of times we need more comprehensive data than that. We need to be able to figure out whether the stream is within the tolerances that are allowed by law, and also that are basically designed around the tolerances of the fish that are in the streams and other aquatic wildlife. So if we can get a particular temperature on a particular day at a particular moment with this one, but this one has the ability to take temperatures on a scheduled basis and record those within the instrument itself. So you can get many temperature readings from this throughout a day, month, or even let it go all year long. In general, for continuous temperature readings, we take them in the summertime, usually June through September. We're looking for high temperatures. Usually low temperatures aren't an issue with fish, especially like coho, the salmon that are on the endangered species lists. So that's one of the aquatic species that we're concerned with in terms of making sure that a stream has the temperatures that are necessary for the fry, the young salmon to live and thrive as they're growing older. So in this particular case, what we try to do is set this up to record the temperature once every hour for all those months from June through September. Usually we don't do it in the winter time because the temperatures are cool enough that it isn't a problem. So today what we're going to do is we're going to show you how to set this up in the first place, as far as being able to program it to take the readings when you want the readings to be taken. For instance, we're going to use once every hour, and then you can also program it to turn on at a particular time, turn off at a particular time if you want it. Before we can put it out in the field, we need to make sure that it is calibrated. We're going to have it out there for many months, and we don't want to find out in the end that the probe is not reading correctly. So to do that, we go through a calibration procedure ahead of time, and I'll show you how that's done. We'll also talk a little bit about deployment, where to put it in the stream, and why you're making the choices that you are, and to help figure out exactly where you want it so you can get the data that you're looking for. So there's actually, in terms of coho and other salmonids, there's particular temperatures that ODFW and DEQ have come up with. They're actually codified in state law, and they have a particular range of temperatures and a particular maximum of temperatures. For salmon, you don't want to be anything over 18 degrees centigrade, or that's about 64-65 degrees Fahrenheit. So as we place this in the stream, we are looking to see if those temperatures are ever exceeded during the summer. So that's one of the reasons we set this up usually in early June, maybe even late May, and just let it run continuously, recording once every hour throughout the whole summer season. We can also look at the range of temperatures, how large of a swing from the upper temperature of the day to the lower temperature of the day. That's called the diel cycle, D-I-E-L, diel cycle, and that's just basically means 24-hour period. And you'll see that, of course, in the daytime the temperatures will swing up. As the sun sets, the temperatures will cool off and start to swing down to a lower temperature. And the difference between those can make a difference for the fish, just in terms of whether they're able to find that cool refuge at night or whether it's just hot all the time. So we're looking at a lot of different things with the data, try to figure out how the water temperature is potentially stressing the fish. It's also important where you place the probe. Take a take a look at it at first. You kind of see on this end of it, there's kind of a piece of glass right here, and when it's turned on, there'll actually be a little red light that blinks on and off every once in a while. This is how the data is transmitted from the probe itself to the receiver, and then ultimately to your computer. It uses this window to kind of transmit the data through to the reader. The temperature probe is actually in this little curvy part here. So it's important to know that, because you want to have the temperature probe right where you want the temperature to be taken. So where do we put this in a stream? So we're looking at where the fish is normally going to try to live. So if the fish are smart, they're not going to find a hot area and just hang out in it. They're always going to try to find what's called a cold water refuge, or just an area that's usually in the shade and is the cooler water of that particular area of the stream. So when we're out on the stream trying to decide where to put this, we're usually looking at areas that have roots coming into the stream. Usually there'll be some kind of riparian shade cover in that particular location. And we're also looking for the deeper parts of the stream. They call it the Thalweg, and that's basically the deep part of the channel. Oftentimes we'll be a little bit out of the actual center of the channel because small fish, fry, tend not to be able to handle the swim against the main flex of the current, so they're usually off, kind of to the sides. So we're looking for those areas that are a little bit deeper, because that's where they're going to go, under a bank, underneath a tree or a log or some large woody debris that's in the stream. Oftentimes, if the stream is running east and west, they'll be on the south bank, because the sun will usually be shining across the water, and that south bank will be giving the fish some shade. When we place the probe in the stream, we oftentimes will attach it to a tree root or just anything that's just naturally there. If you're in an area that doesn't have any riparian cover or doesn't have any large woody debris within the stream, then we can put in either rebar, maybe a 2-foot piece of rebar, or something called a T-stake, and we basically just pound those in to the ground. We'll attach this. Quite oftentimes they're attached upside down, because you usually want to get the area where the temperature probe itself is down relatively near the bottom. You don't want to put it in the sand, but you do want to get it near the bottom, because that's generally where the fish are going to be hanging out. But you also want to be in the deeper areas, because you're having this probe in for the entire summer. So at some point in time, the stream is going to get shallower as the water drops, especially if you're dealing with small streams like we have here in the watershed. Oftentimes they're only a few inches deep in the summertime. So you want to make sure that you found those areas where you can keep this temperature probe in the water throughout the summer, because if it comes out of the water really at any point in time, it kind of ruins your data set. So really important for that reason too. So the deployment is also critical in terms of not allowing the probe to be easily visible. Vandalism or theft can happen even if you're way out in the middle of nowhere where you think nobody is going to be. Fishermen get all over the place in local streams, and if it's very obvious, you'll find that people will sometimes just pick it up, leave it sitting on the bank, they'll throw it somewhere, they'll just steal it, sometimes they'll actually stomp on it or crush it. So anytime you're deploying equipment in the area where the general public can get to, you want to try to hide it as much as possible. That's one of the real advantages of trying to attach the probe to the underside of a piece of large woody debris or a branch or something that you find in the stream. Now, of course, you want to make sure that branch or piece of wood isn't going to move either. If the water, we get a big rain, the water comes up a little bit, you want to make sure that it's going to be where you put it. So kind of have to balance those things and make sure that you're attaching it somewhere where that's very stable, but also out of sight from the general public. Okay, so one other thing I wanted to talk about before we go on to the actual calibration of it is there's so we've talked about wanting to have this continuous temperature readings for the once every hour all throughout the summer. As a part of the law that talks about streams needing to provide temperatures that are appropriate for salmonid rearing, they've come up with something that's called a 7-day maximum. And what that means is that you take, it's actually a 7-day average maximum, and the idea is you look throughout the summertime, and every 7-day period you look at the high temperature for each of those 7 days, and you take an average of it. And then on the next day you drop that previous day and add the following day and take another 7-day average maximum. So this is sort of a continuously rolling kind of set of data that it always has the average of the previous 7 days. And that's the number that they actually use to determine whether a stream is meeting the requirements for the temperature of the stream. So for Coho, it is 18 degrees centigrade. So you would just take your 7-day average maximum starting from that first week, and then moving one day, getting a new average every day, clear throughout the summer. And you look at all those averages and you see if any of those are over 18 degrees centigrade. If they are, or if even one of them is, then it actually creates an issue with that particular stream, and it's put on something that's called a 303D list, which means that there's an impaired water body that needs to have action taken to fix it. So when you're looking at deciding whether this stream is going to properly rear fish, at least for temperature wise, this is one of the important criteria that they look at. Another thing is, as you're setting up your program, and we talked about deployment earlier, another thing you want to kind of figure out is where to put it within the longitudinal aspect of the stream. How much, are you going to put it low, or are you going to put it high, in the middle? And so we talked about already that you want to put it in a shaded area, but there also might be other areas that you want to know whether the water is warming up as it goes through maybe a big area that has no shade. And those are the kind of things that you can put several of these, maybe 5 or 10 of these up throughout a stream reach, and then each of those will be showing you different maximums throughout the summer, and that can help you decide where you need to plant riparian zones, plant more trees, things like that. So if anything is exceeding that 18-degree maximum in one area but not in another, then you want to spend your resource money to improve things in those areas that are not meeting the standard. Okay, so the first thing we need to do is to calibrate this. This is done by putting the probe and our NITS thermometer, which has this long cable, and generally what we'll do is kind of put this through the hole, because we know that the probe's temperature is right, temperature sensor is right here in this curve. So we will put these into water baths and check to see if the probe is reading the same thing as our NITS thermometer. We do it in 2 different water baths. One is an ice bath, and one of them is considered a room temperature bath, which is about 25 degrees centigrade. The upper one doesn't necessarily have to be exactly 25 degrees, just sort of want it somewhere in the ballpark. You want it to be over 18 degrees centigrade, because you definitely want to have that particular temperature within your tested range. So 25 is generally considered kind of an appropriate temperature, and is semi-room temperature for most places, so it's relatively easy to get your water at that temperature. So what we'll do is, first thing is go to our computer and set up this to read once every minute for its recording, and then we will start it on exactly the 0 point, so that we'll kind of synchronize our phone or our watch with the time in here, so that we will know when it's taking the temperature, and then we will take a manual temperature with the NITS thermometer at the same time. By doing that, we'll be able to look and we'll do that about 5 times over 5 minutes or so, and then we'll do it in the ice bath, and then we'll do it in the warm water bath. We'll then download the data from this and look at it and compare that to the readings that we wrote down from our NITS thermometer. We'll compare the two, and hopefully if we can get them within 0.2 degrees plus or minus, if this is within that range of the NITS thermometer, then we're good to go, and we're confident that this is taking the readings that we want to, and that they're both accurate and precise. So I'll get that set up and get the computer set up, and I'll be back to show you that. Okay, so we've moved inside, and we're going to get the probe programmed to be able to perform our calibration tests. So the first thing to use is this Hobo optical USB base station, which is oftentimes just called a reader. And this can read more than just the particular one probe that we're using. It can do various ones. And so if you don't have that particular probe, you can find that this end piece actually comes off, and you're able to slide whatever one that actually fits your probe onto it. And then if you look right here, it says align here with a little arrow. And then your probe also has a thing right here that says COM alignment, communication alignment, with a big arrow. And so basically what you want to do is line up this arrow with this little ridge here, which lines up with the alignment arrow. And you just kind of slide them together. And it can be a bit of a push, so don't feel odd about giving that a pretty good shove. The other end of the cord is just a standard USB. So let's get our laptop open here. And we're using a software called HoboWare, and it is made, of course, by the Onset company just for this purpose. So we'll go ahead and plug our USB port in. And if you look down at the bottom of your screen, and you're probably not going to be able to see that, but it actually reads out the serial number of the probe once you get it connected. And so you just want to make sure that matches this serial number that's written on your probe. So in our case, ours ends in 782, which is correct. So we're good to go. Let me see if we can adjust this so you can see the screen a little bit better. So up at the top, you have some choices up here in the upper left-hand corner, and one of them is, kind of starting from the left, you have a launch device, and if you hover your mouse over it, it'll tell you these: readout device, device status, and stop device and select device. So right now we're going to do device status. So you click on that, and that will open up a window over here, and you can read the name of the device. It'll give you the serial number. The name is actually right in here, and right here, this one says Empire Doc Richard, so that was actually one we used in class a couple of years ago, and so we're going to actually change that because I'm going to be using this probe in my lamprey work and need to have it appropriately named. One of the important things up here is to check for the battery status. It says good. Memory used is the next one, and this has 0 out of 64 kilobytes. So these are older probes, so they don't have a lot of memory in them. And it tells you other things like the number, last time it was launched, the deployment times that it's been launched, and one of the important things is right here, which is logger is stopped. So you want to be sure to look at that, because if it says the logger is active, that means it was put away without being stopped, and you're probably not going to have much of a battery left. Okay, so we've checked the status. Now we're going to go back up to this selection over here that says launch device, and click that. This little pop-up screen says the logger has not been read out. Launching the logger now will permanently erase any data. So we probably have the data from the class that we did last year or a couple of years ago, and we don't really need that. So I'm just going to go ahead and say yes. We're just going to go ahead and get rid of that old data. And it's thinking here a second. Okay, so it comes up with the kind of logger screen that is hopefully able to give us a little information on how to add the appropriate time intervals for our logger. So the first thing is the name. So there's that Empire Doc Richard that we're going to get rid of. I'm just going to say Lamprey Survey. And I'll put a date on there, 2020. It's got the serial number that we looked at before. It still says the battery state is good. Right down here it says temperature and pre-deployment. So that means this is what we're using this for is the pre-deployment check. So we're going to just leave that at pre-deployment. If you go down one more step, and let's see if I can get you to see this. And it's not the greatest, but basically this says logging interval, and right under here it gives you a drop-down box that allows you to pick up different times, and we're going to put 1 minute for that. And the reason that we're picking 1 minute is because we're doing the calibration at this point, and we want to be able to get a reading every 1 minute so that we can tell when to put our manual thermometer in and take a reading. So we're going to take a look. We've got this synced. I already synced this with my phone, so I'm going to pull up my phone and look at the time. And I'm going to launch this. There's a little button down here that says start logging, and you can say now, or you can say at an interval, or on a time and date. So we're going to pick now, because I'm going to just wait till it's 26 even and then say go. Okay, and that's all there is to it. You come back up to the status button, the same one we pushed in the first place. You open that up, and it's really important to do this. You look at that current status symbol that last time said that it was stopped. Now it says logging. So it is active and logging, and that's what you want to see. So say OK. And at this point, our probe is ready for our calibration tests. And so we'll go back out and get that going. All right, so we're ready to get started with the actual calibration effort. And before we do that, I wanted to just sort of do a quick review, make sure we all are on the same page about why we're going through all this. So we're going to deploy this soon. This is the early April, and we probably won't take it out of the field until probably October, at least late September at the earliest. So we really want to make sure that the data that this is collecting is accurate, because if it's not, then we really wasted 6 or 8 months worth of work, and it's a lot of effort just down the tube. So our goal here is to make sure that the continuous temperature probe is reading the same temperatures that the NIS thermometer is reading. To do that, we're going to put it in 2 different temperature water baths. we've got a bucket or a cooler full of ice water here, so that'll of course be down around 0, 1 degrees, somewhere in there, for our low temperature. And then for our high temperature, we want something that's above 18 degrees. So 18 degrees is that, sort of magic number for a lot of the cell-mounted rearing safety zone. So we want it to be at least that, and they recommend usually having it around 25 degrees. So kind of room temperature water. That'll kind of bracket the zone where all of our data that we collect should be between those 2 points. So if we can show now that during our pre-deployment period that these two match and are being accurate within this range, then we're pretty well assured that the temperatures that we get through the data collection throughout the next few months are going to be accurate also. When we pull the temperature probe out of the field, like next October, we'll also go through this same process again, and that's sort of put an end point. So if we can show pre-deployment that the temperature probe is reading right, and post-deployment that the temperature probe is reading right, and we actually also do field checks about once every 2 weeks, and we show that all those temperatures are matching what our known temperature is, then we can very reliably state that the temperatures that we have are right from the probe. And this is sort of critical because sometimes it gets right around that 18 degrees, and it makes a difference whether it's 17.9 or 18.1 or something. So you want to have accurate data. Okay, so the way we do this, get this started, is we take the probe, and I've just kind of used a paper clip and kind of bent it around and put a fishing weight on the end of it. And this is going to just sink the probe down to the bottom of the water we have in our cooler, and just sort of keep it there while we take the measurements. So we do that, and at the same time we want our temperature probe to be inserted in here also. So I'm going to put it right in through this. Remember that this curve is where the temperature probe is within this probe, and this tip is where the temperature is actually taken on our digital NIST thermometer. So I'm just going to kind of stick it right in through there, and then just lower the whole thing into the water. There, it came out, so we're just going to stick it back in there and just kind of watch it as it goes down, make sure that it stays in there. And the probe actually is it floats, so it's actually not sitting directly on the bottom. It's about an inch or so above. And I'm going to maneuver this so that the tip of the probe of the digital thermometer is right there where we want it. Okay, we're just going to leave that for about 5 to 10 minutes. Let everything equalize. During this next 5 minutes or so, I won't be videoing because it's kind of boring, but I'm going to be stirring this water up just to make sure that the water itself is well mixed, and we're not getting any kind of weird stratification of the water or any kind of weird zones that might kind of mess us up. Okay, so we've let the water stabilize and let the probe stabilize inside along with this. And so if you remember right, we set this up on the calibration over on the computer. I made it so that the probe would read when my watch was at the 0 mark. So what I'm going to do is record the temperature on the NITS thermometer, and exactly at the 0. So it's at 24.9 degrees. So you should have a copy of this. I think Morgan probably loaded this onto the website. So this is the form that we use to record. Up at the top it tells you the name of the project, the site location, the GPS longitude, latitude, the elevation of the site that we're going to eventually put this probe at, the temperature logger ID, the serial number, and a little description of the site, my name and telephone number. And then down here you've got a site for your low temp, right here for low temp, and you write the time down. It's 7:01, so we have to take another reading. And we're at 25.0. So I'm writing these down right here. So it's kind of hard to see this, but I wrote the times down because I knew when we were going to start. So at 1900 hours, I took the first one. At 1901 minute, I took the second reading, and we're going to do that for the next 5 minutes. Now we can't tell what the continuous temperature probe is doing yet. We have to hook that back up to the computer to get that data off. So we'll leave this column blank until we're able to read off of the computer. Then the next thing we'll do is we'll calculate the difference. And if you actually have this whole form is actually a piece of software that you can use, and it'll calculate that difference and then grade your answer. We got number 702 now reading, and we're at 24.9. And so I wrote that here in this third column there, and eventually we're looking for this status to be a grade A, which it means that the difference between our probe and the NITS digital thermometer is less than 0.5 degrees centigrade. So that's what we're trying to make sure that our continuous temperature probe is reading within a half a degree of the NITS thermometer. 703, we'll read our temperature again. And again, we're at 24.9. And I'm just going to stir this up gently. Sure we don't get any weird things going on with the water. And insert that back in the right place. Okay, that's just about right. And once again, I'm just keeping my eye on here, and it's 7:04 right there. We take another reading. It's like we're at, if you can read that, 24.8. So that's be our next reading. 4.8. And that's the fifth reading. So you could take another one at 19:05 if you wanted. That'd be over the full 5 minutes, although we've already got the 5 readings, which is usually what I do. But we'll go ahead and read one more. So this is now the high temperature reading. So remember, this is one we were trying to get somewhere around 25 degrees. I just happened to get right at 25 degrees, almost kind of an accident. It doesn't have to be that close. You can just, as long as you're in the ballpark, in somewhere around 23 to 26 or somewhere in there, you're fine. Okay, so 7:05, and again we have 24.8. So we're good on that. So we're now going to move the probe out of this bath and into the ice water bath. Again, just kind of make sure that stays somewhere around the probe. Give this a good stir. Now we can't do this right away. We have to kind of let that settle in and get the temperature stabilized. So we will we'll cut right now and then get back to this in about 10 minutes. Okay, so we've waited about 10 minutes for this. I've already filled out the times on here. We're going to do it at 1915, 1916, 17, 18, 19, and 20. And that will be our read times. And once again, we're going to put it under the master temperature unit because that's what we're doing off of our NITS thermometer. This is the low temp one because we're doing it in the ice bath, and this is all under the pre-deployment temperatures. And I stirred it up right before this, so we're good to go on that. And so basically at this point we're just waiting on our clock to get to exactly 7:15. And when that happens, we look at our NITS thermometer, and you can see it without the reflection. It's 0.4 degrees Celsius. So in this column here, I'm just going to write 0.4. And whenever you write a decimal point that is below 1, always put the 0 in. It just kind of clarifies it, make sure people don't miss the decimal point being in there. Okay, we're just going to do that for the next 5 minutes. We'll do one more and then I'll cut out. So we've got another 15 seconds here. And there it is. So we're still at 0.4 degrees. That just gets put down in the next column under 916, 0.4. All right. So I'm just going to keep doing that for the next 3 or 4 minutes. Okay, so we're finished with the actual deployment in the ice bath. I pulled it out of the ice bath, and as you can see, we've got the numbers completed down to the 1920 or 720 when we finished. So now what we have to do is figure out the temperature units, this column here. And the only way to do that is to read the data off of your temperature probe. So we're kind of back at my computer. Here's our reader again. I line up the arrow with the arrow on here and push them together. And a lot of times it works just to plug and unplug the USB port to get it to read. And then you can set that aside. It has shown up here at the bottom with my serial number, so I know it's reading. I'm going to go up to the top one again and do the status button again. And click on that, and it says it's still logging, which is good. And so it didn't like foul up or something along the way. So that's okay. So now what we're going to do is stop the logger. So there's a stop device button up in the corner here. You click stop device. It says, do you want to stop logging? Yes, we do, because we're finished with our calibrations, and says the logger has been stopped, and we'll click off of that. Now we want to download the data from the logger, so we come up and hit the read out device button, which is the second one in from the right, or from the left rather. So it goes through that and reads it out and asks you where you want to store it. And so for this one, I will actually just put it on my desktop for the moment and say save. And then it asks you, do you want the units in Fahrenheit or Celsius? I'm going to change that to Celsius, and tells you, you can kind of click some of the other items, whether it's good battery, bad battery, when was the stop time, and all that kind of stuff, and just kind of click whatever you want to be able to see, which is, I just leave them all checked, and then you click plot on the bottom. So I'll bring this closer. So there was the units, temperature, and then the various things that you want to see on the readout. So sorry this is so horrible on this video. Okay, so there is your plot for the data. So remember we turned it on, or actually calibrated it, or actually programmed it earlier in the day, and then I came back kind of after dinner to do the actual test. So that's where you see it go up. It went into the warm water bath, and then it goes down, all the way down there to be in the ice bath. And then there's data up here that also shows the actual readouts, and that's what we're going to use right now. So right up here has the dates and times and the temperatures that you're using. But rather than using this tiny little screen, you can go up here to File, and then come down to Export Table Data. You click that, and then it'll ask you basically the usual kind of stuff, like where you want to keep it and stuff. And you just click Export, and this is pretty intuitive, so don't worry about it if you can't see it on the screen very well. And you just tell it where you want to save it, and it saves it. So I saved it to the desktop, and if you click on it, it will open it up in an Excel file. And so here it all is. And let me get it closer so you can kind of see a little bit better. And so this is when we first started logging. I'm going to double click here so we can see our times and dates. So we want to go to when we first started on our sheet. Over here, you remember it was 1900. So for the time, that was when we were doing our high temperature. So we want to look at 1900, 1901, 1902, all the way through 1905. So I'm just going to go through the Excel sheet until I can find those times. And there they are right there. So there's 1900, and there's the temperature that the logger read right there. So you highlighted it there, which is 24.646 degrees. So we're going to put down 24.5. We'll round it off to 1 decimal point. And then the next one is 24.48. It's right here, so it's also 24.5. 24.5. And if we just continue on down, they're basically all the way down to 1905, which was our last one. They're all going to round off to 24.5. So we'll write those down on our data sheet. Okay, so now that's kind of what it looks like. So I've just written all these 24.5s in here. Now we're going to compare this to this. We're going to subtract the two and write the answer on there. The reason these are zeros is because this is copied off of an Excel spreadsheet that you can actually make it do it by itself. So we'll just kind of cross these zeros out and put in what the right answer is. So the very first one is 24.9 minus 24.5 is going to be 0.4 degrees. And the next one is 25.0 minus 24.5, so it's going to be 0.5 degrees. And if I just continue on down, I'm seeing 0.4, 0.4, 0.3, and 0.3. So I wrote those right in here next to it right here. Okay, so in order to get a grade A, we have to be within 0.5 degrees. Those all are, so basically we get a grade A on all of our high temperature readings. Okay, now I need to go back over to the low readings. Once again, sorry if this is bad video. So we started up our low readings at 1915. We did 1916, 17, 18, 19, and finally 1920. So I'm going to go to the Excel screen and look for 1915, which is right there, if I can get it in. And we got, you can read that on your screen, is 0.852. 0.8. Okay, so 0.8. And the next one is, for 1916, is 0.742. So 0.7. And I'll just read off the rest of them. The next one is for 1917 is 0.66, so it'll be 0.7 again. The next one is 0.577, so once again 0.6. And then it goes to, at 1918 is also, actually we're on 19, so it's 0.4, and that's, I stirred it halfway through right about then, so that's why that probably changed by that tenth. And the next one is 0.356, so we'll round that off to 0.4 also. Okay, so once again, there's my master temperature that we got off of our NITS thermometer. These are the ones I just wrote down. I got off of our logger. So I'm going to subtract these two and put the absolute value. Doesn't matter whether it's higher or lower. So it's going to be 0.4, 0.3, 0.3, 0.1, 0.1, and 0.1. And once again, they had the zeros in there, so just kind of cross those out, and those figures right there are what we're looking at. So once again, we're within 0.5 degrees of all of our readings, so we would indeed get a grade A status for our probe on the low temperature also. Okay, so with that, we are ready to deploy our logger. It's been, we've got it recorded with all the data. We've got it checked out for our pre-deployment in both low and high temperature. So all that's left to do now is to program the probe for taking temperatures every hour instead of every minute. So we'll have to do the same thing we did previously with the, we'll close out of the Excel file, and this is wanting me to save it. I'm just going to close this for now. I don't need it. Don't save. And I'm going to open up HoboWare again. I'm going to go back to plugging this in, and I'm going to pull up status. And this is that same screen we were at before. Once again, I apologize, this is such a horrible video. Let's see if I can get any closer. Okay, so this was the screen where we were looking at the status. So our logger is stopped right now. So that's okay, that's what we expected it to be. So that's good. So we're just going to close that. And then we're going to launch it by clicking up there in the corner. Okay, once again, we've got our label that I have as Lamprey Survey 2020. We've got the serial number. The battery state is good, so we definitely want to check that because it's got to be out there now for 6 months. We want to make sure that that is right. We're going to do the temperature. So this says configure sensor to log, and we did pre-deployment first. And now I'm just going to put stream temp. And the most important part of this is down the next section here where it's asking for the log interval. So right here it says 1 minute right now. We don't want to do it one every minute, or if we do that every minute for 6 months, we'd have way too much data. So we're just going to kind of arrow down until we get to 1 hour. Okay. You can also do it every 30 minutes. It kind of doubles your data. You end up with literally twice as much data, which is okay. I've done it at 30-minute intervals before, and I don't see a big advantage of it. You know, this is sort of a gradual thing that happens throughout the day, so that extra half-hour reading doesn't really tell you that much. Okay, then we go down to the next thing. It says, when do you want to start your logging? And I'm going to put on a date and time. So I'm going to plan on putting this out on April the 6th, on Monday. I'm going to click on that, and then I'm just going to put down, I probably won't be out that early, but I'm just going to put down 8 a.m. because it's okay if it starts beforehand. In fact, you want to make sure you really do start beforehand. Okay, so there is 8 a.m. So I'm ready to go. We've got all of our things checked. We've checked our battery. We've made sure that the logging interval is 1 hour. And we've got our date and time to start it set. So you just click over here in the corner. Right there, it says delayed start. So basically I'm going to click that. Sorry, this is getting bouncy. And then I actually get a error message that says could not write data to the device. So it's got a launch error. So I'll figure out kind of what that means. Must have done something wrong, and I'll go and fix that. But that basically is the way that the calibration and setup for deployment works. The next video we'll do is of actual putting it in the field. Walk outside here, it's getting dark. We're going to put it into an area in Eel Creek where the lamprey are kind of known to spawn, and I'll probably use rebar to pound that in. and attach the probe to the rebar with a cable tie. And that's it for now. Thanks, and we'll see you next time.